Hello. Sorry for the late recording. I promised to record on Tuesday, but it wasn't possible for us. So we were able to create time today to record this video for you. It's important to note that for tomorrow, of course, this video you will watch it for the class for tomorrow, and also there will be a homework for you that you do after the video. You have to submit the homework to AHAN. So it's important you watch the video first. If you know the concepts already, you can just do the homework, but it's important you watch the video if you want to clarify some of the points about geometric sequences. So, and they will give you some information regarding this on the classroom page and as to how you are going to do the homework and what is expected of you, when to submit it, etc. Okay, welcome to this class today. What we are looking at is geometric sequences. I need to figure out how the board works. I don't know if it is on pen or not. Okay. Exponential sequence is another name for geometric sequences. I want to talk to you about the word series. We are not looking at it now, but I thought it's important for you to know what a series is. Like we talked about what is a sequence previously. We said a sequence is an arrangement of numbers or objects that follows a defined rule. That is a sequence. Now, if you take the summation or if you take the addition of these numbers, that becomes a series. For example, if you write the sequence 2, 4, 6, 8, etc., and then this one is 2 plus 4 plus 6 plus 8, etc. So this is a sequence. If you add them together, you get a series. So we are going to look at geometric sequences. What are the elements that tells you that this sequence you are seeing is geometric and not arithmetic? Remember, we already looked at arithmetic sequences. So what do you look for when you are finding out if a sequence is arithmetic or geometric? There are two things that I will mention here. The first one I'm going to talk to you about is the first term. This applies to every sequence. Every sequence has a first term, okay? Meaning it has a starting point, and then also there exists what we call a common ratio. All right. For a sequence to be arithmetic in an arithmetic progression, or for a sequence to be an arithmetic sequence, we said there exists a common difference. Before we looked at that already. Common difference. But for a sequence to be geometric, there must exist a common ratio. Now, a ratio mathematically is when you express terms in forms of fractions. For example, A over B can be written as the ratio of A is to B. So, if two terms are next to each other, you have a sequence that follows each other. If you take the ratios, that can give you a geometric sequence. Okay? So let's investigate the following sequences. Let's look at the following sequences. What do we have here?
This one, if you look at it, you have powers of 2. For example, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4, 2 to the power 4 is 16. Alright? This other sequence is you multiply it by 0.5. Okay? So that is 1 times 0.5. That gives you 0.5. Now 0.5 times 0.5, that gives you 2.5. So, sorry. That gives you 0.25. Alright? So to get the next term, always multiply the previous term by 0.5. So in this other one, we said multiply 6 by the next term to get the previous term to get the next term. Otherwise, you could say these are powers of 6. 6 to the power 1, 6 to the power 2, 6 to the power 3, 6 to the power 4, 6 to the power 5, etc. That is what you have there. So multiply by 3, multiply the first term by 3 to get the second term, multiply the second term by 3 to get the third term, multiply the third term by 3 to get the fourth term. So the terms that you are multiplying by is what is called the common ratio. The common ratio. So in this case, the common ratio is 2. In this case, the common ratio is 6. In this case, the common ratio is 5. In this case, the common ratio is 3. Now, so looking at it, like I told you, because it's a common ratio, you can get it from the sequence itself. So if you want to get the common ratio, is the second term, this is the first term, the second term, the third term, the fourth term. So the second term divided by the fourth term, the ratio of the second term to the first term, that should be the same as the ratio of the third term to the second term, 8 by 4. That should also be the same as the ratio of the fourth term to the third term, 16 over 8. So if you look at this, 4 over 2, 8 over 4, 16 over 8, this is all giving you 2. So if you divide the first term by the second term by the first term, that should give you the common ratio. Or if you divide the third term by the second term, that should give you the common ratio. Or if you divide the fourth term by the third term, that should give you the common ratio. So if you want to investigate that a sequence is in geometric progression, just take the ratio of the second to the first, or the third to the second, or the fourth to the third, and see if that is equivalent. So once you have a common ratio, then that particular sequence is in geometric order. So, like it says, the ratio between every consecutive terms in a geometric sequence are called the common ratio. This is the value each term is multiplied by to find the next term. So analyzing the common ratio and predicting the different terms in a geometric sequence is key to solving many real-world problems. Geometric sequences are used to model patterns and form predictions for events based on these patterns, such as savings, accounts, populations, and radioactivity. There are lots of real-life situations in which you can apply the existence of problems to which is in geometric sequences. So let's now look at some examples of finding the common ratio in a geometric sequence. So this example here, you have the sequence 4, 2, 1, 0, and 5. So if a sequence is AN and the first term is A1, the second term is A2, the third term is A3, The fourth term is A4. If you want to get the common ratio, which is represented with R, is equals to the second term, A2 over A1. In this case, the second term, R will be equals to the second term, which is 2, all over the first term, which is 4. Or R will be equals to 1 all over 2, the third term over the second term. Or R will be equals to 0.5 over 1. Now, any of these answers will give you R as 0.5, or it will give you 1 over 2. Let's look at some more examples on finding the common ratio for a given geometric sequence. If you have the sequence 32, 64, 128, 256, I can already see this is 2 to the power 5, this is 2 to the power 6, 2 to the power 7, 2 to the power 8. So you could see always the sequence can be expressed as an exponential term as well. So if a sequence is like increasing in an exponential form, mostly that sequence gives a geometric sequence. So you could see that. Now to get the common ratio for this sequence, always, like I said, divide the preceding term by the previous term. The preceding term, the term that is after, by the one before it. Not the one before to the after, the one after to the one before. Preceding, in this case 64 divided by 32, or 128 divided by 64, or 256 divided by 128. So divide 64 by 32, or divide 28 by 64, or divide 256 by 128. So that's it. Each of these will give you the right answer. 64 over 32 will give you R. If you simplify that, how many groups of 64? How many groups of 32 are in 64? I mean, it's 2 times. Okay. Otherwise, 128 and 64. So R is equals to 128 divided by 64, which is also 2. If you like, R will be equals to 256 divided by 128, which is again 2. So the common ratio always divide the preceding term by the previous term. The term that is after by the one which is before. Okay, that always gives you the common ratio. So you can find the common ratios of the next 2 sequences. Find the common ratios of the next 2 sequences. 64, 48, 36, 27. 64, 48, 36, 27. So 64, 48, 36, 27. So 64. I would say this is 3 to the power 3. This one is 36. Okay, so to find the common ratio, you basically divide, like I said, 48 all over 64, which should be equals to 36 over 48, which should be equals to 27 over 36. If you simplify that, 48, so 2 goes into 4, 2 times into 8, 4 times, into 6, 2 goes into 6 is 3 times, into 4, 2 times. So 24 and 32, it can go, it goes into 24, that is 3 times, into 32, that is 4 times. So what you have is 3 over 4. Okay? If you use 9, into 27, that is 3 times. 9 into 36 is 4 times. So basically, if you simplify that, you will also end up having 3 over 4. So the common ratio there is 3 over 4. So for the last sequence, 1 minus 4, 16 minus 64. So it's minus 4 over 1, which is equals to R, or minus 64 over 16. So which is just minus 4. So the common ratio there is minus 4. So you can see those answers there as well. So when you are given any two consecutive terms, 2 or 3 or 4, and that these terms are in a geometric sequence form, you can always find the common ratio by dividing the terms next to each other. So the one that becomes the numerator is the preceding term, and the one that becomes the denominator is the previous term. So the term after divided by the term before, that gives you the common ratio. It's very important for you to note that. So to verify that a sequence is geometric, you always prove. Look at the first two terms and see if the ratio that they give you is the same as the ratio between the third and the fourth term, or the third and the second term. If that is so, then this is in a geometric sequence order. So, what do you think? Take a moment to answer the following questions. Is the following sequence a geometric sequence or not? So think about what I just told you, and then no. If you have thought about the answer, no, yes, it is not a geometric sequence, you are right. So look at it. Whether if you take the ratio between the second term and the first term, if that will be the same as the ratio between the second term and the third term. So if I look at these numbers, it's easier to prove for these three numbers. So how do I prove for these three numbers? I know 2 all over 4 should be the same as 1 over 2. 2 over 4 should be the same as 1 over 2. But also look at it there. If you have 12, 8 over 12, is that the same as this answer? So because this one is true does not mean all of them are true. So you have to test for all the values as well. So looking at that, what you have is 8 over 12, and now is 12 over 24. This should also be the same as 24 over 48. So the odd one is 8 over 12. So because of that, this is not a geometric sequence. This is not a geometric sequence. How about this one? Find out if it is a geometric sequence. What is your answer? Yeah, it is a geometric sequence. Take the common ratio. What is the common ratio? So if you divide 2 by 8, let's say 2 over 8, how much will that give you? This is like 1 over 4, and that is 0.25. Yeah, 0.25. So if you take the division, you will always have that for each of the. How about this one? 1, 9, 18, 36, 72. This is like 9 to the power 9 times 1, 9 times 2, 9 times 3,
No. I was thinking it's in that order, the sequence is in that order, but it is not. Alright, is it a geometric sequence? Yes, it is a geometric sequence. Alright, 18 divided by 9. This is 2. 36 divided by 18 is 2. 72 divided by 36 is 2. So the second term divided by the first term, that answer is the same as the third term divided by the second term, and that also is the same as the fourth term divided by the third term. This is not a geometric sequence. Alright? Tell me why. Maybe you can ponder why. Try to find out why is it not a geometric sequence. Divide 10 by 5, divide 15 by 10, divide 20 by 15. But I can already see that there is a constant difference between the first term, the second term, the third term, and the fourth term. Then it is an arithmetic progression because it's no common ratio. What you have is a constant difference. A sequence cannot be arithmetic and at the same time geometric. It can either be arithmetic or geometric or none of the two, because you have other sequences that are not arithmetic at the same time they are not geometric. So we have more sequences to investigate. Maybe when you study further mathematics in your later years or when you go to university, you can look into those. But right now our concentration is on arithmetic progression and geometric progression. So I will run through these questions quickly. You can just look at them and then try to answer the correct answer for yourself based on what you see. Read the options. Yeah. So once you establish that the condition for a sequence to be geometric is there must exist a common ratio, then multiply the common ratio to the last term of the sequence and then continue multiplying for the specified number of terms. For example, find the next 3 terms in the sequence. So it is the common ratio now that you found out that you can use to multiply by the last one to get the next one. So for example, if the sequence here is 1, 5, 25, 125, and I ask you to write the next 3 terms of this sequence, the next 3 terms, 1, 2, 3. Now, first you need to know what is the common ratio. To get the common ratio, we already know the second term divided by the first term, that is 5. So the common ratio is 5. 5 times 1 is 5. 5 times 5 is 25. 25 times 5 is 125. So if you multiply 125 by 5, that will give you 625. And that continues. If you multiply 625 by 5, that will give you 13125. Right? If you multiply that by 5, it will give you 15625. And that will be the answer for the next 3 terms of that sequence. You can see it down there. Alright, the common ratio is 5. Multiply the last term by 5 to get the next one. If you get the next one, multiply it by 5 to get the next one to that. If you get the next one to that, multiply it by 5 to get the next one to that one as well. And that continues. Always multiply the common ratio by the last term to get the next term. So, if the sequence is given to you, which we already investigate, you are going to use the common ratio to find the next 3 terms of this geometric sequence. Just multiply the common ratio by the last term to get the next one. Multiply that by the common ratio to get the other one, and so on. And that will give you this sequence here. The common ratio here is 2. 6 divided by 3 is 2. If you like, 12 divided by 6 is 2. Or 24 divided by 12 is 2. That gives you the common ratio. Once you get the common ratio, multiply it by the last term. 2 times 24 gives you 48. 2 times 48, that gives you 96. 2 times 96, that gives you 192. So if you want to get the next term to this one, you multiply 192 by 2 to get the next one. And that continues. In a similar way, this sequence here is in geometric form and the common ratio is 5. 15, so common ratio is 3. 15 divided by 5 is 3, or 45 divided by 15 is 3. If you like 135 divided by 45, it will still give you 3. So the common ratio is 3. To get the next 3 terms, multiply 135 by 3, that gives you 405. Multiply 405 by 3, that gives you times 3. That gives you 1215. Multiply it by 3, that gives you 3645. So if you multiply 135 by 3, you will get 405. So that's it. So if you get the common ratio, just multiply it by the last term, that gives you the next term. That's how the next 3 terms are generated. So take a moment to find the next term in this geometric sequence. So first you need to find out what is the common ratio. To find the common ratio, the second term is minus 12. When we divide that by 6, 6 goes 1 into 12 is 2 times. So what you have is minus 2. So 96 times minus 2. So 2 times 6, that is 12, carry 1. Okay, 90, that's 180. 180, 180, 6, that's 12, 192. So that gives you 192, but because it's minus, so it becomes minus 192. So the correct answer is option D, which is correct. Correct option is D. So always find the common ratio. If you get the common ratio, you can always multiply to find the next term, or the next 3 terms, or the next 10 terms, or the next 15 terms. But yeah, we will come to look at the ratio formula, the geometric sequence formula, the n-term formula, and then that is even easier, because if I ask you, for example, to find the next 15 terms of this, the 50th term of this sequence, that is in the long position. If you have to find it next after that, it will take you a lot of time. But you can generate a formula and use the formula to find the end term of the sequence. Yeah. So all these are following you to find the next term. To find the next term in this geometric sequence, you need to establish the common ratio, which is 1 over 4. And if 1 over 4, 1/4, 1 times 1 over 4. This is just 1 over 4, because the last term is 1, multiplied by the common ratio, R. This is the last term, is 1, multiplied by the common ratio, it will give you 1 over 4. So the correct answer is 1 over 4. Find the next term in that geometric sequence. Again, since it's a geometric sequence, the common ratios are the same. Divide to get the common ratio and then multiply it by the last term to get, which is going to give you B if you do it rightly. So try it on your own. Find the common ratio. Divide 15 by 6, for example, or divide 37 by 15, or 37.5, sorry. Or divide 93.75 by 37.5. This is all giving you the common ratio. So if you get the common ratio, multiply that by 75. So multiply that by 93.75. That answer should be right there, which is option B. If you did it the right way, it will give you option B as the correct answer. So there are more examples on finding the common ratio and the subsequent terms of a geometric sequence. I will make the PowerPoint available to you. You can take your time to go through them. Right? You can look at these options also, look at these answers as well. Try the work out for yourself. If you have any problems, you can always text or ask about. Looking at the recursive formula. Now, first, Just like we looked at it in the arithmetic sequence, we are going to look at it in the geometric sequence form. Alright? So, similar to the arithmetic sequence, geometric sequences can also be written using the recursive or the explicit formula. Now, why do we need the formula? For example, if you are giving a geometric sequence, for example, you are giving the geometric sequence 1, 4, 9, 16. This is the first term, the second term, the third term, the fourth term. And I ask you to find the 100th term. Meaning, you are going to continue 5th, 6th, 7th, 8th, 9, up to the 100th term. So imagine, of course you can do it, but it will take a longer time. So if you get the formula, the geometric formula, the recursive formula, or the explicit formula, you just have to substitute 100 for n, and then simplify using the first term and the common ratio. So what is it doing for you? It's giving you this whole process with respect to A and R, because the first term is A and R is the common ratio. Remember, if you multiply the first term by the common ratio, it will give you the second term. If you multiply the first term, the second term by the common ratio, it will give you the third term. But essentially, that is what it is giving you. So, looking at the recursive formula. In the recursive formula, A1 is the initial term, that's the first one, not the second one. Alright? And R is the common ratio. So, to get the n term, which is an, is equals to an minus 1, a sub n minus 1 times r. Now, if a is 100, if n is 100, like here I said, find the 100th term of this sequence. If you are finding 100 terms, so n will become 100. So this will be a100 minus 1, which is a99. So remember, always the last term before the 100 term is the 99 term, the term in the 99 position. Alright? That times the common ratio will give you the 100 term. Remember, always the last term of the sequence times the common ratio gives you the next term. So in this case, the next term is 100. So you multiply the 99 term by the common ratio to give you the 100 term, and that's the recursive formula. A sub n is equals to a sub n minus 1, meaning subtract 1 from n, from the n term, multiplied by the common ratio. So this is the last term of the sequence. This is the n term of the sequence. So an is the nth term, and a sub n minus 1 is the last term. So, and r is the common ratio. So if you multiply the common ratio by the last term, what will you have? That is always giving you the next term. Alright? So that's the recursive formula there for you. That's the recursive formula. So let's practice it a bit, because writing the formula in that form so this is the geometric sequence. So sequence, not series. Sometimes I confuse this word. It's not series. Series is a sum of a sequence. It's the addition of a sequence. So always if I say series, I'm not meaning that. We are not looking at series right now. We are only concentrating on sequences. So A is 0.5. That's A1. A2 is minus 2. A3 is 8. A4 is minus 32. I'm putting it this way so that you can see that this is the first term.
This is the first term. This is the second term. This is the third term. This is the fourth term. So the recursive sequence is always the common ratio, because we are finding a formula. You need the first term, okay? You also need the common ratio, all right? So in this case, the first term is 0.5, and the common ratio R is when you divide minus 2 by 0.5. I will take the whole numbers, 8 divided by minus 2, which is minus 4. Or if you like, minus 32 divided by 8, which is still minus 4. Or better still, minus 2 divided by 0.5. That will still give you the same answer. So this is A1, which is the first term, which is 0.5. And then the common ratio is minus 4. So always the n term is equals to a sub n minus 1 times r, which is the common ratio. And in this case, a sub n is equals to a sub n minus 1 times 4, because the common ratio is 4. All right? A sub n minus 4. Exactly. So always you will need to find the first term and the common ratio in order for you to be able to write the recursive formula. Find the first term, find the common ratio, and then write the recursive formula. An is equals to a sub n minus 1 times r. So you need r. Once you get r, substitute it in the formula, and that gives you the recursive formula for each of the sequences. So virtually look for r in this sequence, substitute it there. Here too, look for r, substitute it there. Look for r, So like I was saying, just get the first term and get the common ratio, substitute it in to get the recursive formula. So in this case, the first term is 3, the common ratio is 2. So put the common ratio in the formula an, which is the n term, that is equals to the last term, an minus 1, multiplied by the common ratio, which is 2. So in a similar vein, the common ratio is 3, substitute it in there to get the recursive formula. The common ratio is 1.5, substitute it in there. Common ratio is 2/3, substitute it in there. So virtually, I know that the first term is 1/4. So the first term here is 1/4. This one is minus 1/4, so it's out. This one is 1/4. There is possibility for this one. This one is minus 2/3, minus 3/2. This one is out. So the correct answer is one of these two sequences. In order for you to find that out, which one is right, you have to investigate the common ratios. So it means divide the second term by the first term, 3/8 divided by 1/4. If you simplify that, it's 3/8 times 4/1. 4 goes 1 into 8, 2 times, you have 3/2. All right? So the answer here is minus 3/2. If I look at this sequence, they are all positive. This one is negative, so the possibility for it to be negative is on letter C. So the correct answer is option C. Option C is the correct answer. Yep. Find out which sequence is recursive and it represents this formula from the list below.
If you get it right, the correct answer should be option B. Do the same thing, pause the video, find out which sequence is described below by this recursive formula, and then check your answer. If it is option A, you are right. Now let's look at this table of geometric sequence for the sequence above. To find the 17th term, just multiply the 6th term by 2, because the common ratio is 2. 6 by 3 is 2, 12 by 6 is 2, 24 divided by 12 is 2. So the common ratio is 2. So if you know the last term, multiply it by 2 to get the next term. So to find the 17th term, just the 7th term, just multiply the 6th term by 2, right? Exactly. So that's how you can always expand. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. In terms of A1 and R, this is, what is the common ratio? The common ratio is 2. So that is what you write. This is A1 is 3 times 2. This one is 6 times 2. This one is sorry. So AN is 3. So A1 is 3. So this is A1. So this one is A1 times R. So this one is A1, A2 times R, A3 times R, A4 times R. And if you put that in number forms, you could see that it is the common ratio that is increasing in power form. So here is 3 times 2 to the power 0, which is 1. 3 times 2 to the power 1. 3 times 2 to the power 2. So 3 times 2 to the power 3. 3 times 2 to the power 4. So the next one is 3 times 2 to the power 5, and that continues. So that is what you have there. So basically, AN this is AN, and that will be A R to the power N. Yeah. Minus 1, depending on which term you are finding. So the n term of a geometric sequence is AN now is equals to A times R to the power N minus 1. So anytime you are finding a geometric sequence, multiply the first term by the common ratio to the power N minus 1. So that gives us the explicit formula. Alright? We already investigated the recursive formula. This gives you the explicit formula. So with the explicit formula, the common ratio is what? Increase in power form. Huh? Alright? Let's look at an example. So to find the explicit formula, you need to first find the first term and also the common ratio. Alright, once you get the first term and the common ratio, you can always write the explicit formula. The first term is 1, the common ratio is minus half. So this is, first term is 2 rather. So that is 2 times, the common ratio is minus half, minus 1 over 2 to the power N minus 1.
So if you get the first term, A, and you get R, it's always AR to the power n minus 1. So what you need to find is A and R. You need to find the first term and the common ratio. If you get the first term and the common ratio, you can always simplify it to the explicit formula and find any given term. Even the last term you are asked to find, you can find the last term. And always it's important to note that AN is equals to AR to the power n minus 1. This is always giving you L. If a sequence is with 4 terms, 1, 4, 9, 16. If I ask you to find the 5th term of the sequence, the 5th term is the last term there, because there are 4 terms right now. If I ask you to find the 5th term, A5, the 5th term will be A5. If I ask you to find A5, A5 is going to be A is 1, R is 4 divided by 1. 4 divided by 1. Is it the common ratio? This is 9 divided by 4 is not equals to 4 divided by 1. So this is not a geometric sequence. So I am getting to know that. So let's look at this sequence here. So if I have to write the 5th term of the sequence, I first need to investigate what is the common ratio. The common ratio is 2. So this is A5 will be equals to, the first term is 3 times the common ratio, which is 2 to the power n is going to be 5, because we are finding the 5th term minus 1. So this is going to be 3 times 2 to the power 4. 3 times 2 to the power 4 is 16. 3 times 16. 3 times 6, that's 12. 42. Yeah. So in this case, the next term will be 42. But yeah, that's the 5th term. In that case, is the last term in that sequence. So always the explicit formula gives you also the last term. Anytime you have the explicit formula, that could also represent the. How do you write the explicit formula for this sequence? For you to be able to write the explicit formula, you need to remember that AN is equals to AR to the power n minus 1. Now, if you can remember that, you need to find A and R from the sequence here. A is equals to 3 and R is equals to 2. How do you get R? Divide 6 by 3, 12 by 6, 24 by 12. Anyone should give you 2. So if you get A and R, put them back in the formula. AN is equals to AR, A is 3 times R is 2 to the power n minus 1. So some will put this in a bracket to be in the receiver side, but you can also write it as 3 times 2 to the power n minus 1, or 3 into 2 to the power n minus 1. So that's the first one you could see. What you did in the first one, you can do the same thing to get the second one, do the same thing to get the third one, do the same thing to get the fourth one. Yeah? So which explicit formula describes the geometric sequence? Pause a minute and then find out the answer. Find the first term, find the common ratio, and then see which one is represented there. The correct answer should be option C. If you get it right, yeah, it should be C. Alright? Look at that other one also. Find the explicit formula. Sorry, this one is asking for the common ratio. The formula is given, you're asked to find the common ratio. Maybe I need to write this for you clearly. This is AN is equals to minus 2 times 3 over 2 to the power n minus 1. What is the common ratio? The common ratio is clear there, but you are asked to find it. The correct answer should be option D. You can see the common ratio here, 3 over 2. Always the common ratio is what has the power n minus 1. Which is the initial term of the geometric sequence? Initial means the first. So the initial term is the first term. And always we said the first term multiplied by the common ratio to the power n minus 1. So the first term here should be minus 7 over 3, which is option A. Which explicit formula describes the sequence? Find the common ratio, find the first term, and put it there. Find which answer. Option B should be the correct answer. Alright? Do the same thing, pause and then look for the answer. Always when you have the question, pause the video and then write the correct answer. If the answer is correct, you should have option B. Alright? Yeah. Finding a specified term. Finding a particular specified term. So this time it could ask you to find the 15th term. A series is existing, you have a sequence, but you are asked to find the 15th term. Maybe the first term is giving, maybe the second term is giving to you, maybe the third term is giving to you, and you are asked to find the 15th term. Or you are giving some information in which you can use to find the first term and the common ratio. And once you get the first term and the common ratio, you can always find the n term. So any given term that you are asked to find, key information for you is how can I find the first term? How can I find the common ratio? If it is a geometric series or sequence rather, find the first term, find the common ratio. Once you get the first term and the common ratio, you should be able to find any given term using the explicit formula. Remember, an is equals to ar to the power n minus 1. Now, for example, if you have a as 5 and r as 3, and I ask you to find the 100th term of this sequence. To find the 100th term, this will be A100, n becomes 100. That is equals to the first term, 5 times the common ratio r to the power n is 100 minus 1. So this will give you 5 times r, now we know is 3 rather. This is 3. So this is 3 to the power 99. So you can find the value of 3 to the power 99 using your scientific calculator. The symbol, the power symbol is that. If you press 3, press the power symbol, press 99. That should give you how much is 3 to the power 99. Then multiply that by 5. That should give you your answer. Alright? So always, once you get the first term, you got the common ratio, you can find any given term. So always, first, find the n term for this sequence. A is 3 and r is minus 5. The same thing, n is 10. So in this case, A10, the 10th term, is equals to 3 times minus 5 to the power 10 minus 1. Minus 5 to the power 9. 10 minus 1 is 9. If you expand that, multiply your answer by 3, that should give you the A20 is the 20th term. A20 is the 20th term. To find that, this is 3 times 2 to the power 20 minus 1, which is 3 times 2 to the power 19. If you simplify that, you should get the answer. How do you simplify that? This is 3 times 2 to the power 19. On the calculator, press 2, press the power symbol, which is that, times 19. Otherwise, 2 to the power 19 means 2 times, 2 times, 2 times, 2, up to 19 times, which is very difficult to put on a normal calculator because we have only 9-digit space. So it's best to use the power symbol. Once you press 2, press the power symbol, press 19, that should give you that answer. Multiply that by 3, you should have the answer to that question, which is a very huge number. It's 1,572,864. That is what you should get when you do the multiplication right.
Again, pause for a minute. Try this answer to find the particular term that is given to you. For all of them, pause the video and then find what is asked, what is being asked. Alright guys, I will pause for now for this video, and hopefully you are able to answer the questions that are assigned to you on the classroom page for you to test your understanding about geometric sequences. I will give you the PowerPoint for this lecture as well. You will have the rest of the PowerPoint slides for you to go over if you want to verify certain information, and do not hesitate to email us, either Andy or me, when it comes to questions about the lesson. And if you have questions about the homework marking, or you want to get some answers about the giving homework, you can email Ahana for that response. Thank you all for your kind attention.